All right. So what I want to do is go through the last section in Chapter 3, which is just continuing the idea of factoring, okay, from what we've already talked about. So the steps for factoring should be always look to remove common factors first. Okay, so once you complete this step, or if this step does not apply, you can move to the next step, which was to find special factor forms. And we saw in the last section that finding special factor forms kind of depends on how many terms you have. Okay, so if you're dealing with a binomial, so two terms, the special factor forms that you look for are the difference of squares, or the sum and difference, or sum or difference of cubes. Okay, if you find those, then go ahead and apply those rules. When you're looking for special factor forms and your expression has three terms, you're looking to see, does it fit a perfect square trinomial? And then finally, if you are looking for special factor forms and it fits, and your expression has four terms, you're probably going to do what we're going to talk about today, and that is you're going to follow the steps for factoring by grouping. Okay, so let's take a look at how you would factor by grouping here. Okay, so if you were given an expression that looked like the following. Okay, so as you're going through your steps, there's no common factors to remove. There's no special factor forms here, but it does have four terms. Okay, this indicates that we're probably going to factor by grouping, and if so, we're going to follow these steps. Okay, so the first step in factoring by grouping is going to be to group each pair of terms. Okay, so we have our first pair of terms and our second pair of terms are grouped together. Notice I didn't do anything yet. I will physically draw in an arc to show that I'm grouping those terms. And once I group them, what I'm going to do is apply this top rule, and I'm going to remove any common factors from each group. Okay, so when I look at this first pair of terms, what common factors can I remove from those two terms? Numerically a 3, and variable-wise x to the power of 2, whatever the smallest power is. When I do that, what's left is going to have the same form as the original, one group minus another. So if I took 3x cubed and I divided out a 3x squared, what's going to be left? Just the x. And if I divide negative 6x squared by 3x squared, I'm going to be left with a negative 2. So do the same thing with my second pair of terms. Remove any common factors. You're always going to remove this sign, so it's a plus sign. What common factor can I remove from 5x and negative 10? Just the 5, and that leaves me with x and a minus 2. Right? If I've done this right, what you should see is in this last step, you're going to be able to remove a common binomial factor by just the process of factoring. Okay, so the last step here is to remove this common binomial factor. And this is just by factoring, what we did in the last section. So we take out our common factor. It's a binomial factor x minus 2. And what we're left with is going to have the same form as the original. One group plus another group. Just so happens that when you take out the x minus 2, the first group is going to be left with 3x squared. The second group, when you take out the x minus 2, it's just going to be left with 5. The other way to think of this is when you remove this common binomial factor, and you'll see me do this marking, I'm just going to be left with the factors 3x squared and plus 5 become the terms of my other binomial factor. And that would be your simplified form. All right, so I want you to try this next example on your own and see if you can factor the following. All right, so in this one, you remove any common factors first, none to be removed. Look for special factor forms. Well, you have 4 terms, so let's look to see, can we factor by grouping? When we group these together, the first pair of terms has a common factor of what? X squared, and that leaves an x and a plus 5. The second pair of terms have a common factor of 5. Again, we always take out the sign, so a negative 5. And the negative is going to change the sign of each of these terms. So if we divide negative 5x by negative 5, leaves us with a positive x. If we divide negative 25 by a negative 5, leaves a positive 5. If we've done it right, we should have a common binomial factor, which we take out, x plus 5. And then whatever remains, the factors that remain become the terms, x squared and minus 5, of our remaining binomial factor. We would look in each of those cases to see, can you factor anything further? If so, do that. If not, you're done. In this case, there's no additional factors, so we're good.